Right, before I show you my next or latest acquisition, let's explain what's happening about this Tektronix scope that I said I was looking at on Gumtree. You know, I was looking at a Tektronix 475 scope that someone was selling on Gumtree in a sort of non-working condition. And I contacted the seller, and initially he said he was away at the time, and yes, it's still available, and he'd get back to me. And a couple of days passed, and I contacted him again, and oh yes, bear with me, I'm still very busy, I'll contact you in a couple of days, you know, same old thing, and nothing happened. And I'm thinking, you know, okay, this has been dragged along a bit, does this scope actually exist? And then I got another message from him day before yesterday saying I'll be around probably at the weekend. And I said, oh okay, let me know when and I can come and have a look at it. And then it all went quiet again. And then the next thing I know, he sent me a message saying, oh, the scope's no longer for sale. I've sold it to someone locally. And well, you know, I'm communicating through text messages, so I replied back without being rude. I said, well, thanks for wasting my time, and you know, basically just said, you know, what about first come first serve? You know, I mean, he said no one else had been interested in it before then, and then now he's suddenly sold it to someone locally. What difference that makes, I have no idea. Anyway, sold this scope locally. Funny enough, his name was Richard. I don't know, it was Richard Head. Anyway, yeah, so what it's boiled down to is the scope is not going to materialise. I don't even know if it actually existed. I'm not sure if it was a ploy to try and persuade him to sort of like send it to me by post. I was going to pay sort of like 40 quid for postage, and then he would just never send it and then vanish. So I left some sort of like a you can leave sort of feedback on Gumtree, and I left him a sort of like a note saying, you know, don't trust this chap, he's a crook, and yeah, so that's where we're at. There is no scope. Don't think there ever probably was any scope. Not the end of the world. As you know, I'm not short on scopes, and I'm also not short on frequency counters, but that doesn't stop me buying another one. This is a Philips PM 6668. It's a lovely little instrument actually, and it's a very small, as you can see, small little form factor. I bought this with actually very, very small money actually. This obviously person hadn't got a clue what the value of they are. They usually go for sort of like 150 quid, something like that on eBay, because it's a 1 gigahertz example. I paid nothing like that, that's for sure, for it. And it was sold as, not sure if it's working, genuine seller, you know, not sure it was working. It's supposed to have an internal battery, and they said they didn't know if the internal battery was flat. Well, obviously it is. This is an old sort of late 70s, early 80s Philips counter. Just put the stand up so you can see the display a bit easier. Trying to get the light right way. It's the exposure correct is always a bit of a tricky one in here. So yeah, it turned up today, and it comes in it's nice. It comes in a little plastic carrier case, which is quite nice. You can see it's plastic carrier case it comes in, which is lovely. So it's the markings in the back on the photograph shows that it's got no battery on it. There's no battery option listed, but it has got the transistor controlled crystal oscillator, so it's got a slightly better crystal oscillator in it. So I wasn't actually expecting the battery inside it, but I thought it a bit strange that the seller was actually saying it had, you know, he wasn't sure about the internal battery. Maybe this was a meter that he used to use and he knew it had an internal battery in. But I was quite surprised, as I say, when I opened it up, it had all the control gear for the internal battery, and the battery was absolutely flat. Powered it up, and you see it works. It powers up. The little screen is up and running. I'm trying to get some better light so you can see. Maybe if I bring the camera down a bit and then move it up, maybe that will be better. Is that better? Better contrast, isn't it? So the display is clearly working. No idea of its accuracy. I don't know when it was last calibrated. The lovely thing about it is the manual is really in depth. It's got a sort of like a quite a detailed fault finding chart of if it comes up with various error messages. But I thought we'll have a quick look this evening to see how well it performs, and plug it into my up-control crystal oscillators I've got warming up on the bench at the moment, and have a look, compare it with the Raykel Dana that was recently calibrated. See how far it's off. Now it's been on for about half an hour now. You probably need a little bit longer than that to warm up, but we could get an idea of how far it is out by now, because this is a transistor controlled oscillator. It shouldn't be too bad with temperature change, as long as it's not ridiculous. It's not going to have the accuracy of an ovenized oscillator, but it should give me a fairly reasonable account of what it's doing. So I think the first thing to do is, if I dig out the oscillators, it's quite simple. What I'm going to do, I'm just going to connect the 5 megahertz input to the the right hand channel. And what it does is this signal generator frequency counter has got 2 inputs, and up to 120 megahertz this right hand input selected, and then it will automatically select to the other range if it detects a signal. So what you can actually do is you can parallel these inputs, and actually it will automatically select which input it thinks is best. We've got a manual sensitivity control on the right here. Basically we've got a power on and standby switch, standby being allowing it to charge the battery when the power's turned off. And the faster sample rate on the right. So let's plug this into the this ovenized oscillator. These 2 references I've got here that I made a couple of years ago. Zoom out so you can see these. This is just a 5 and 10 megahertz reference oscillator. Not super precision, not like rubidium standard, but it's certainly good enough for this particular counter. So let's just plug that in, and what we'll do is I'll see what we get. So I'm going to plug that into the right hand channel, and let's see if we get anything. Turn the sensitivity down a bit. There we go. 5.00004 megs. I'll zoom in a bit so you can see. So not a mile out, but slightly out, I suppose. Just trying to get some better. Very difficult. This is the trouble with LCDs. They're really hard to see unless you get exactly the right angle. And it's always worse with a camera. It always seems to make it worse with the camera. I can see it quite clearly. Okay, so that 5 megahertz is showing 5004. Let me just check the 10 megahertz input. I expect the same sort of error. Okay, so we haven't got so many decimal places, but it looks like it's pretty good actually. And what I'll do in a minute is I'll just check to make sure that this 5 and 10 megahertz are actually correct by plugging them into the Raykel and doing a check. Now, if they are really slightly out, there is an adjustment inside, and it's clearly listed in the manual to try and just trim the transistorized oscillator. Now, that's an option on these. They can be removed, and it will just run on its internal standard crystal oscillator, which is not so good for aging and things like that. So I'm going to let the unit warm up for a minute. I'm going to take the cover off, and we'll also check the calibration of my oscillator. What I could do is actually get the rubidium out, but I don't think it's really necessary with the counter of this resolution. So let me let it warm up, and I'll confirm the accuracy of my source, and we'll go from there. Okay, it's been on for about nearly an hour, I suppose now, just under an hour, and you can see the 5 megahertz is showing. So what's that? It's 100 kilohertz, 10 kilohertz, 1 kilohertz, 100 hertz, 10 hertz. Showing 4 hertz fast on the counter. Now I've checked the source of my ovenized oscillator here on the recently calibrated Raykel Dana, and it is spot on. So the counter is showing slightly quick, slightly fast. So what I'm going to do is we're going to take it apart and see if we can bring that back in again. So let me just get into a better position. I'll show you inside move it away. I don't want to power it when it's whilst I'm taking it apart. I want to ideally leave it plugged in, because if I leave it plugged in, it's going to warm up quicker. Just take the plastic cover off. Now this is, as you know, I've probably got this other Philips counter that I use occasionally, and I love these counters. The one thing nice about these counters is if you suddenly think, oh, I need to check something with the counter, if it's a non-ovenized counter, you can be pretty sure that if you plug it in and switch it on, even though it won't have the same resolution or ultimate accuracy as an ovenized oscillator, it will work straight away. There's no warming up period. You just plug it in, and it's ready to go. So here's the inside. Zoom in so you can see a bit better. This is where the battery obviously used to sit. A couple of connectors here. We've got Kapton tape around them where the battery's being removed. Now the oscillator is actually behind this shield here. The adjustment to the oscillator is behind this shield here. So I'll whip this cover off. Now I'm doing this with it on. There's obviously low voltage in here, but I have to be a bit careful about shorting anything out. I don't want to blow it up when it's obviously clearly working. Okay, and I can see the oscillator here. Let's show you. I've got a stretchy mains lead I've found at work, which is quite useful. Get the torch. Let's see. And you can see that trimmer capacitor, left hand side, or on your right hand side, is that trimmer capacitor just centre of the. And that's the adjustment for the normal oscillator. We're not using that one because we're running on the transistor controlled oscillator, and that one is that one there. Now that's great, isn't it? That's really easy to get to because we have to come through the board here, and this is all part of the this part of the board here is the charging circuit for the battery. And unfortunately, if you remove that, the unit won't work, because when you fit this option in, this battery option, there's a TO220 regulator that bolts on the side of the unit down here somewhere. I think it's probably where that you can see that chamfered hole is, that countersunk hole is where the transistor used to bolt in. So I can't actually remove that to make the adjustment. So I'm going to have to sort of try and go in probably with a pair of needle nose pliers and have a tweak to just bring that oscillator up. These other connections here, these two resistors at the top, pots here, are to adjust the charging voltage and the warning when the battery light comes on, so they shouldn't need adjusting. We've got a pot on here, just shows the light flares everything out, but you see that pot on the left of the screen, or the left of the unit. It should be the right of the unit actually, the right of the unit. I think the image is reversed. That pot there. That's adjustment for sensitivity for the changeover point, I think, of when it switches from which input it's going to use. So let's get that connection connected back up again. There's clearly not much wrong with this. I know everyone wants me to change all the capacitors, but they certainly look okay, and I'm not going to bother changing them unless I think it needs changing. As I say, I don't tend to shotgun capacitors just for the sake of it. If the unit starts messing around, or there's a problem with noise on the screen, just ripple and stuff, or it's jumping around or something like that, or it starts to act strange, then I'll start looking at capacitors. But at the moment, looks like it's working okay. So let's reconnect it up to the source and see if we can get that adjustment in. Let's get it into a point again where you can see. Maybe if I zoom right in, it will give you better exposure. Very difficult to get a viewing angle on this. It's pretty hopeless, isn't it? Right, let me get this. Trying to get this so you can see it. I think that's the best I'm going to get. It really is very difficult to see this. It'd be nice actually if you could fit some backlights on this LCD display. That would be a quite nice addition. Something like the Solitron meter's got, so you can actually see the thing in low light. Might look into that. A couple of LEDs maybe in either side of the screen. Might be just enough to illuminate it. It really depends on how well the light spreads across the display. Okay, so we're at 5 megs. I'm going to go in here with my pliers and try to tweak this tuning capacitor. So, a bit fiddly. A metal tool, which is what they tell you not to use. See it coming down. Just on the verge of 9, all the 9s I want. There we go. Just up a little bit. And it actually tells you to set it to all the 9s there. So 4.999. Just clicking over on the 5 megahertz, as you can see there. So that's looking better. So what I'm going to do is I'm just going to disconnect the ovenized oscillator and feed it back up to the Reikaldana, just to confirm that our frequency has stabilised. I'm just going to click that up and I'll move the meter up, the camera up so you can see. And where are we? Up a bit higher, there you are. And there's the Reikald confirming that it's just under 5 megahertz. So that was pretty straightforward. So let's get it back together. Let's get the thing back together and we'll have a go and see what it works like. Okay, I'm just going to run through the performance check of the manual, and it's here. It gives you a list of the sensitivity of the instrument. We're not interested in the frequency. We know the frequency is accurate now. I've connected up to the Marconi signal generator. I'm going to run through a couple of the tests just to see how it performs. The first one is on the low frequency input, so that's what we're on now. It says set a sine wave generator with a voltage of 50 millivolts RMS. So amplitude, I'm just setting the generator up now, 50 millivolts RMS. And then set the sensitivity control to 50 millivolts RMS, which it is. Check the counter correctly displays any value in the range of 100 Hz to 75 megahertz. So basically I've got to put a frequency in now. So let's put a frequency in, a carrier frequency of 55 meg. And you can see the counter is showing 55 meg. So that's good. So the sensitivity is correct, that looks okay. Adjust the sine wave generator output to 25 millivolts and let me just check. Adjust the sine wave generator output to 25 millivolts and check that the counter displays correct values. So basically we're not overloading the front end, so the amplitude of 25 millivolts. Initial glitches, the attenuator kicks in on the Marconi, and you still see we're at 55 megahertz, that's okay. So let's try a couple of different frequencies. 75 meg. Yep. Let's go 10 meg. And let's go down, so it's got anything up down to 100 Hz. Obviously the Marconi won't go that low, and I think I can go down to about 80 kilohertz before it becomes unleveled. So let's go, that's 80 megs. Let's go carrier frequency 80 kilohertz. That's working perfectly, so that's fine. So the sensitivity seems fine on the low end, so that we're not worried about the low frequency. That's working correctly. Now let's go to the high frequency. I haven't got the whole thing screwed in yet because I've only just put it back together. And now we set the signal generator to minus 24 dB. RF level minus 24 dB. And anywhere from 700 megahertz to 800 megahertz, 70 megahertz to 800 megahertz. So let's go 70 megahertz. And it's not showing that, so let me just check I'm doing this right. So high frequencies, so it's the 50 ohm input, which is that one. Set the signal generator to a voltage of 50 millivolts minus 24 and check that the counter correctly displays the value in the range of 70 to 800 megahertz. Well, it's not, so I'm still on the wrong frequency. So let's go 70 megs. Okay, that's good. That's working. So that was my mistake. I was still on the low frequency. So let's go 800 megahertz then. Look at that, perfect. It's working fine. So the sensitivity of the unit seems to be fine. Now it does say that when you go up to the higher frequencies, you have to increase the input of the unit. It doesn't actually say here. Oh, set the generator to 25 millivolts or minus 19 dB, and check the generator correctly displays 1 gigahertz. So this, for just out of interest, let's not change the level. Let's just go to 1 gigahertz. So 1000 megahertz. Look at that. Even with the reduced level, it's still showing the correct frequency. So there's absolutely nothing wrong with this little counter. What a nice little counter it is. It's certainly useful on a battery with an internal battery, because you know, if you're working with sort of stuff where you want an isolated supply and you want this thing totally isolated from the mains, you know, if you're working on sort of equipment that's floating above 0 volts, you can actually use this on a battery supply, and you don't have to worry about earth loops or anything like that. It will be a totally self-contained unit. So that really sums it up, this little Philips counter. It's worth keeping an eye out for these. As you know, I've got the other little Philips counter I restored a couple of years ago. That's only up to 120 megahertz, but the great thing about that, it's got trigger levels and things. You can actually adjust the triggering to get accurate and smooth triggering on sort of like non-sinusoidal waveforms. This is a bit more limited with that. It's got much higher range, and it's got a manual sensitivity adjustment, but you can't adjust sample rates apart from fast and slow. The other Philips generator has other Philips counter has a more or less a constantly variable sample rate, which can be really nice for some things. Adjustable AC and DC coupling for measuring on the top of waveforms and things like that. So if you've got a DC offset, you can actually either capacitor couple it, or you can actually pull the level up and down to get the point where you want to actually trigger on the waveform. So that's always useful. Okay, so that sums it up with this little counter. I hope that was of some interest. I'm sorry that the oscilloscope never turned up, but the bloke obviously wasn't ever going to sell it, and I think it was possibly tied up to a scam. I'm not sure. It seems a very poor excuse to when he knew I was interested for sort of like weeks on end, and then suddenly say that he sold it to a local person. Smell a rat there. Anyway, thanks for watching.